This is an accident that never should have happened. Dave Smith has always been a careful worker, but today he got careless while using hand tools, and it almost cost him his eyesight. Unfortunately, Dave's case is not unusual. There are over 10,000 deaths and almost 2 million disabling injuries resulting from work accidents each year. Many of these are the result of improper use of hand tools. Overall, the cost is a staggering $33 billion a year. We all share in this cost: the injured employee in lost time and wages, the employer in lost production and workers' compensation, and ultimately all of us as consumers in the higher cost of products. American tool manufacturers are well aware of the importance of tool safety. They make every effort to design safety into their products. Materials are subjected to many tests before they're formed into tools. The finished tools are also subjected to rigorous testing and inspection before they reach the marketplace. Manufacturers do their part for safety. Ultimately, however, safety rests in the hands of us, the tool users. Hand tool safety is based on common sense and a few basic safety rules. Always wear approved eye protection and clothing. Select the correct tool for the job and use that tool correctly. Inspect your tools regularly and maintain them in safe condition. Always be aware of the warnings and instructions offered by the tool manufacturer and never modify tools. If Dave Smith had observed these rules, he wouldn't be in the hospital today. There are hundreds of types of hand tools available. Each tool is carefully designed and manufactured to high standards to perform a specific job safely, properly, and with confidence. Using tools for a purpose other than that intended by the manufacturer could lead to serious personal injury to the tool user and possibly to others nearby.
Let's first talk about wrenches. There are a few important rules that apply. Always select a wrench with a correct size, inch or metric opening. Loose-fitting wrenches not only make the job more difficult, but also round the corners of the fastener. Never use cheater bars. Using a pipe extension or other form of cheater to increase leverage can cause the wrench to break or slip. Serious injury can result. Do not push on a wrench. If the wrench should break loose or the wrench should slip, you could bang up your knuckles pretty good. Take a balanced stance. Always pull on the wrench and be prepared in case the fitting breaks loose or the wrench slips. A cocked wrench can damage the fastener or it can slip and cause injury. Use an offset wrench for those difficult to reach fittings. There are many types of wrenches. In fact, there's a design to meet just about any need. They include box, open, combination, striking, adjustable, pipe, hex, structural, torque wrenches, and many others.
Here is one of the most widely used wrenches. The box wrench is the preferred choice whenever possible since it completely encircles the fastener for a secure grip. Specifically, box wrenches are used for final tightening and breaking loose fasteners.
If extra force is needed to remove a frozen fastener, a striking wrench should be used. These wrenches have extra bulk built in at critical points and feature a specially designed striking surface.
The open-end wrench is another widely used tool. Special patterns of open-end wrenches are available for specialized applications such as tappets, ignition, structural, set screw, and many more. Open-end wrenches should never be used to break loose or final tighten a fastener. However, they're ideal for quickly snugging up or removing a loosened fastener.
The combination wrench provides the convenience of a box and open-end wrench in one tool. Each end should be used as previously described.
When using a hex-type wrench, be sure to use the correct size to prevent damage to the wrench or the recess opening of the fastener. Never use a cheater bar or strike the handle of the wrench to gain extra leverage. Serious injury could result. Compact folding hex key sets offer the convenience of several sizes on one tool.
Adjustable wrenches are designed to provide a wide range of capacity in a single tool. They're convenient service wrenches for repairmen and linemen, for example. They're not intended to replace fixed opening wrenches for production or general service work.
Adjustable wrenches should be tightly adjusted to the nut. Always pull so that the force is on the side of the fixed jaw.
Don't use an adjustable wrench to free a frozen nut or to final tighten a nut, and never pull on a wrench adjusted to a loose fit. Pipe wrenches are designed for turning and holding pipes and fittings in service where tooth marks are not objectionable.
When using a pipe wrench, always maintain a gap between the back of the hook jaw and the pipe. This concentrates pressure on the jaws, producing the maximum gripping action and rotating force. Periodic cleaning and inspections will detect any worn or broken teeth, in which case the jaws should be replaced.
Never use pipe wrenches on fasteners or square stock, such as a pipe tap on an extractor.
A type of wrench that is often thought of as a separate tool category is the socket wrench. Its speed and efficiency make it a popular choice for many applications. Their proper use includes the same general rules as those for other wrenches. Use the correct size wrench and socket. Never use cheater bars. Take a balanced stand with feet securely planted. Pull on the wrench, never push on it. Socket wrenches have square drives that range from 1/4 inch to over 1 inch. Select the proper size socket wrench and socket to handle the job without overloading the wrench. 8-point sockets are for use on square nuts and bolts. 6 and 12-point sockets are for hex nuts and bolts. When using a deep socket, be careful not to cock the socket. If there is too much play, the socket could slip or break and cause an injury. There are 3 types of sockets: hand, power, and impact. They all vary in design and hardness. Knowing the difference between them and the correct application of each is critical for safe use. Hand sockets usually have a bright finish, but some do have a black finish. Power and impact sockets have a black finish and usually have thicker walls. Hand sockets should never be used on power drive or impact wrenches. They can fail and cause serious injury. In addition to sockets, there is a wide variety of attachments available for use with socket wrenches. Socket extensions can prevent damaged knuckles when working in those tight spots. When additional leverage is required, use a flex handle, better known as a breaker bar. Whenever using any attachment, be certain to use the one designed for the tool and use it correctly and safely.
Many applications require that bolts be tightened to a recommended specification. Torque wrenches provide a means of applying the correct amount of tightening to various fasteners. An over-tightened bolt could break under stress, while a bolt not tightened to specs could vibrate loose. Torque wrenches can be divided into 2 categories. One is the direct reading type, which includes deflecting beam and dial wrenches. These allow the operator to read the torque as it's applied. The other category, generally referred to as clicker wrenches, indicates with an audible click when the desired torque value has been reached.
Always apply smooth and steady force to the torque wrench. Jerking causes over-torquing. Never use torque wrenches to free frozen fasteners. Always apply force to handle to ensure proper accuracy. When working with direct reading torque wrenches, make sure that your line of sight is perpendicular to the pointer for accurate reading. Torque wrenches are precision instruments and must be checked for calibration periodically, properly stored, and carefully maintained. Also, read and follow manufacturer's instructions and warnings. For those really tough jobs, a torque multiplier provides the safest and most efficient alternative. Torque input is multiplied several times through the gearing. The solid handle of the multiplier is braced securely against an object strong enough to withstand the heavy torque load. Screwdrivers are among the most commonly used and abused hand tools. They're available in a wide variety of shapes and sizes to match specific fasteners.
The wrong size screwdriver could chew up the screw head, damage the screwdriver, or worse yet, skin your knuckles. A good selection of screwdrivers, properly organized, will solve this problem.
Although screwdrivers are designed solely for driving and withdrawing threaded fasteners, they're often misused for prying, chiseling, scraping, and a variety of other misapplications.
A screwdriver should never be used as a pry bar. If it's overstressed in this manner, the blade might break and send a particle of steel into the user's arm or even into his eye. Never hold work in one hand while using a screwdriver with the other hand. A slip could cause a severe puncture wound.
Using a screwdriver or any tool near a live electrical circuit is extremely dangerous and life-threatening. Don't do it.
If a job involves electricity, the power should be shut off and procedures should be put in place to prevent another party from turning on the power before the job is completed.
Another widely used and easily abused group of hand tools is striking and struck tools. These include hammers, sledges, punches, and chisels. They're made in various types, sizes, and configurations for specific purposes. They should be selected for their intended use and used only for those purposes for which they're designed. While many striking tools may be similar in appearance, their intended, proper, and safe use may differ widely. For instance, nail hammers are designed for driving only unhardened, common, and finishing nails, and nail sets. Nail hammers should never be used to strike punches, chisels, or other struck tools.
The claws are for pulling common and finishing nails and for ripping woodwork.
Never strike one hammer with or against another hammer, as the face may chip, possibly resulting in serious injury. Ball-peen hammers are designed for striking chisels and punches and for riveting, shaping, and straightening unhardened metal. It's extremely important to use the correct size to minimize the possibility of chipping or of foul blows.
The striking face of the hammer should have a diameter approximately 3/8 inch larger than the struck face of the tool. A hammer blow should always be struck squarely with the center of the hammer striking face and parallel to the surface of the struck tool.
There are several types of sledges available in many different head configurations. These tools are designed for general sledging operations.
Hand drilling hammers are used for striking cold chisels, star drills, brick chisels, and hardened nails.
Railroad track maintenance requires the use of some specially designed tools such as track chisels, tie and plug punches, square flatters, rail forks, tongs, and many more. Among the most widely used tools is the spike maul, designed specifically for driving rail spikes. Because of the heavy demand placed on the spike maul, frequent inspection of the tool is necessary to assure that the tool remains in safe working condition.
Any striking or struck tool that shows dents, cracks, chips, mushrooming, or excessive wear should be discarded immediately. Never regrind, weld, or reheat a striking or struck tool. Doing so could alter the temper of the steel and make the tool unsafe. Damaged handles should be replaced. Soft face hammers are intended for striking blows where steel hammers would mar or damage the surface of the work. Never use these tools to drive nails or to strike sharp objects.
There are many other types of hammers and sledges.
There are machinist riveting, tinner's riveting, setting, paneling, scaling and chipping, bricklayer, hand drilling, stone hammers and sledges, mauls, blacksmith sledges, and others, such as the electrician's hammer.
Be certain to select the right one for the job, and always think and practice safety. These struck tools are related to the striking tools we just discussed. Among some of the more commonly used struck tools are chisels and punches.
Cold chisels have an edge for cutting, shaping, and removing metals softer than the cutting edge, such as cast iron, bronze, or copper. Remove small pieces of loosened material a little at a time. Hot chisels are designed for cutting hot steel. Wood and ripping chisels are designed for rough work. Brick chisels are designed for scoring and cutting, adjusting and trimming bricks or blocks. They should be struck with a hand drilling hammer or sledge. Never use a bricklayer's hammer or a nail hammer. Several types of punches are commonly used. Center punches are designed to mark metal and other materials softer than the point end. Pin punches are used to drive and remove pins and rivets, and drift pins to align holes in different sections of material. Blacksmith's round punches are designed for drifting holes, aligning and driving pins.
As you can see, selecting the proper struck tool for the job is an important first decision. Selecting the proper striking tool is equally important.
Star drills are designed for drilling in materials such as masonry, stone, concrete, and brick. Use short, controlled blows when holding struck tools in hand. Use tongs or other proper holding devices when full blows are necessary.
There are possibly more types and styles of pliers than any other tool. At last count, there were over 105 different kinds.
These include needle nose, curve nose, transverse end cutters, concave, and more.
Although pliers are versatile tools for holding, turning, and cutting applications, no single pliers can do everything, and many are designed for a specific purpose. It's important to select the proper pliers for each job. There are also some basic rules that apply to the safe use of pliers.
One way to prevent injury from flying metal is to wrap a burlap bag, wiping cloth, or rag around the cutting jaws so that metal pieces cannot fly. Warn those in the area of the potential danger. Then cut at right angles and don't rock. Never use pliers as a hammer, nor hammer on the handles. Never use extensions on handles for greater leverage. Approach it the safe way. Select the proper size and type pliers for the job. Use larger pliers or a bolt cutter. Never cut live wires or use pliers near live circuits. Plastic-coated handles are not intended to provide protection against electrical shock and electrocution. They are provided for comfort only.
The three principal categories of pliers are solid joint, slip joint, and locking.
Solid joint pliers include those with side cutters, long and needle nose, and various other nose configurations. Never use a needle nose pliers for prying. This could damage the pliers, and if they snap, someone could get hurt. Never bend stiff or large gauge wire with a needle nose. The same risk of breaking exists.
Slip joint pliers are designed for a wide range of services involving gripping, bending, and turning. The slip feature enlarges the opening of the pliers for even greater versatility.
These tools boast the lengthy name, locking pliers and wrench and clamp.
As the name indicates, these are combination tools that function as pliers, wrenches, and portable vices or clamps. While a locking pliers is not intended to replace open-end or box wrenches, it can be used to remove already damaged fittings and fasteners. Never use these tools as hammers or hammer on them. Be very careful. If vibration is present, they may come loose.
Locking pliers are not designed to be used as steps or ladders for load support, lifting, or hoisting. Using them in this way could lead to serious injury.
Cutters are used to cut ferrous materials such as steel wire and cable, rod, wire rope, aircraft cable, guy strand, fencing, bolts, and steel strapping. Other cutters are used for cutting non-ferrous materials such as copper and aluminum. And be sure to select the proper type and size cutter for the job. Follow the manufacturer's instructions or obtain professional advice. Remember that metal flies when cut. The harder the metal, the farther it will fly. Now, another type of cutting tool is the snip. Its primary purpose is to cut thin sheet metal. Snips are also used to cut screening, chicken wire, fencing, steel strapping, gaskets, linoleum, canvas, and other soft, flat materials. There are 5 basic types in common use today.
Select the proper snip for the cutting job and always wear approved eye protection and gloves. Use only hand pressure for cutting. Never use a hammer or extension bars for additional leverage. Do not use to cut hard wires, since blade damage may result.
The vise is sometimes called the third hand, but no hand can hold work as firmly as a vise. It's the indispensable tool in the tool room or home workshop.
There are 8 basic categories of vices and many special purpose vices. While most of these vices can be used for a wide variety of work, it is important to select the vise most suitable for the prime application and strong enough for any work required. The machinist vise is built for heavy industrial use. The utility or workshop vise is intended for light work in a home workshop. The automotive vise is for service station work. For carpentry and general woodworking, the woodworking vise is ideal. The clamp-on vise is used for light work where portability is important. The pipe vise handles plumbing and pipe work. 2 vices commonly found in machine shops are the milling machine and drill press vices. When securing a vise to a workbench, be sure to use bolts in all holes, never screws. Make sure the nut is underneath. Never use the jaws of a vise as an anvil. There, that's better. Many vices have an anvil built in. Here we go again. Cheaters damage tools and cause injury. Don't use them. The handle on the vise has been designed for the proper load. Use the maximum jaw surface possible when securing the work. Never try to bend a heavy rod or pipe in a light vise. The vise could tear loose and you could take a nasty fall.
Another versatile tool is the clamp. It too can be considered a third hand in that it serves as a temporary device for holding work securely in place. Let's take a look at a few of the types of clamps available, possibly some you never even thought existed.
These include the C-clamp, the machinist clamp, the welder's clamp, the bar clamp, the hand screw clamp, the miter clamp, the corner clamp, and the pipe clamp, to name just a few.
In selecting the proper clamp for the job, consider the following.
Is the clamp heavy enough and strong enough for the job? Is the opening long enough to accommodate the work? Is the clamp deep enough to properly secure the work? Is the clamp easily adjusted to the work? And finally, is the clamping surface of the clamp adequate? Never use C-clamps for hoisting or supporting an elevated load. Specially designed clamps are available for this purpose. Never use C-clamps to secure a load for over-the-road transportation. They may vibrate loose and cause an accident. There are many types and sizes of C-clamps. Whichever one you use, don't use a cheater bar or hammer on the handle to gain additional pressure. In welding applications, do not let the heat source contact the clamp, vise, or other tools being used.
We've gone through a lot of material here, but we would be remiss not to include the fact that a well-organized system of tool storage is essential to safety. If the correct tool is readily available, there's less temptation to use a dangerous substitute.
Tools should be organized in a roomy industrial tool storage unit that can be readily moved to the job site. Always push the cabinet for better control, and don't load it up with extra tool boxes or loose items that might fall off or throw it off balance. Make it a habit to lock the wheels. Otherwise, the cabinet could get away from you and cause an accident. Be sure to close each drawer before opening another. Too many open drawers could cause the cabinet to tip over. Someone could get hurt, and that someone could be you.
Hand tool safety is based on common sense and a few basic rules.
Always wear approved eye protection and clothing. Select the correct tool for the job. Use that tool properly. Inspect tools regularly. Maintain your tools in safe condition. Follow the manufacturer's instructions and never modify tools.
There are also some general workplace safety practices that offer further protection.
Be certain that there is proper lighting in the work area. The work area should be clean of oil, grease, and other spills, and should not be cluttered. Always take the time to do a job properly and safely. Turn off and lock out electrical power if you're working on or near electrical lines, and follow your employer's work rules and safety literature.
We hope that this presentation has given you a better understanding of hand tool safety. However, you should study other sources of information for more complete details on specific tools. We recommend manufacturers' catalogs, product brochures, and operating manuals.
Another excellent source is the Guide to Hand Tools, prepared by the Hand Tool Institute. It covers selection, safety tips, and the proper use and care of hand tools. We suggest that you obtain a copy, keep it handy, and refer to it often. For further information, contact the Hand Tools Institute, 25 North Broadway, Tarrytown, New York, 10591.